Hello everyone, my name is Omkar Rasar and today I'm going to explain the Hamming code. Hamming code is a critical technique in the field of digital communication and data storage. This method ensures that the data integrity is maintained during transmission by allowing us to detect and correct errors. Error detecting and correcting code. Errors in data transmissions are inevitable, especially when the data travels over long distance or through noisy environment. There are different ways to deal with errors in data transmission. One simple method a, is to use a parity code which adds a single parity bit to a data word. Parity codes are good for detecting single bit errors, but they can't correct them. Worse yet, they can't handle multi-bit errors. This is where the Hamming code comes in. It was developed by Richard Hamming in 1950. This code is a setup. It can detect up to two simultaneous bit errors and correct one, making it a powerful choice for ensuring reliable communication in various fields, such as computer memory, telecommunication, and satellite systems. The Hamming code overview. Now let's dive deeper into how the Hamming code works. The key idea behind it is redundancy. The redundant bits called parity bits are added to the original data. These bits aren't part of the data itself but are strategically placed to help identify errors. For each integer m, where m is the number of parity bits, there exists a Hamming code that can protect a data word. The total number of bits in the code word n is given by n is equal to 2 raised to power of m minus 1, where m is represents the parity bits which protects the data bits. What's really clever about the Hamming code is how it arranges the parity bits. They are placed at positions that are in power of 2. For example, 1, 2, 4, and 8, and so on. Each parity bit checks a specific subset of bits in the code word. So basically, the parity bit at position 1 checks all odd positions, for example 1, 3, 5, and 7, and so on. The second bit, the parity bit at position 2 checks every second and third position, for example 2, 3, 6, 7, and so on. And last but not the least, the parity bit at position 4 checks blocks of 4 bits, for example 4, 5, 6, 7, 12, and 13, and so on. Each parity bit ensures that the total number of ones in its checked position is even. This even parity rule is the foundation for error detection and correction. So now that we know what is a Hamming code, now let's find out how to calculate the Hamming code. First of all, you need to mark all the bit positions that are in power of 2 as parity bits. For example, 1, 2, 4, 8, etc. Second step, place the bits in the remaining positions. Step number 3, each parity bit ensures even parity for a specific group of bits. For example, position 1 checks 1, 3, 5. The position 2 checks 2, 3, 6, and so on. If the total number of ones is odd, the parity bit is set to 1 to make it even. If it's already even, the parity bit is set to be 0.